was saying that senior will be only 3 questions. So I'm
Nah,
afraid.
let's go.
I'm afraid that's
Let's
Zion's
go.
Please, Zion, come on.
We've got 3 questions.
No, but think about it. Why would Zion just say something like that? I don't think Zion.
Alright, so for Q4, I feel like the more I tried Q4, the more I was like, oh, this is not easy to prove. Okay, so let me try to prove something like. What should I want to prove? I want to prove something like. Okay, I kind of did this in a messed up order because I'm only doing this first. This is the last thing I did, but it's the first thing. So basically, let's try to get. So I think it's obvious that S could be like. Oh, so let me tell you the question. Yeah. So S is closed under multiplication. So the set of positive integers. Yeah.
Just close on the multiplication.
And if you have A, B, and S, so A and B could be the same.
Is that the notation?
Then A, B is in S.
N/7.
Maybe like this. It's like a. Well, it's.
Oh! It's like
What were you using?
I thought that meant closed under multiplication.
Oh no!
That's a thing.
What kind of reputation am I developing here?
Imagine making up
And then like, I'll make another angle. It also implies that A over B ceiling is in S. Yeah.
Yes.
Okay, so clearly S equals 1 is a solution.
Damn.
S equals I'll make a notation here. The powers of A. So this is notation.
Wow.
So 1A squared.
Suspicious notation.
Yeah.
Crazy.
And so basically it just suffices to show like it's everything. It's everything if it contains anything more than that. Yeah.
Isn't that just a positive integer?
Yeah.
What do we need advanced for?
Well, it's some people don't even include 0 in the end. You know, if some people include 0, but this notation takes care of both parties.
Wow, no, I still know people don't include that. I mean 0 in it.
Some people are like, what could be more natural than 0?
Actually.
Why don't you just like?
I don't know. Yeah. Okay, so maybe I can prove a lemma like this. So if you have
I'm pretty sure always
if you have A, actually I wrote this in the overleaf, so maybe I'll just look it up.
Like, if you have
Oh wait,
obviously
if you have A, obviously, yeah.
Wait, you said more.
No, I'm pretty sure.
No, it's not
close.
necessarily the same. So it can be fine.
Right, you want it really close, but you don't. But like if it's hard, you can only get close.
Okay, so basically I have like if you have a B that's not 1, right? And yeah, so one of the things about proving a lot of the things in this question is like if you don't assume that A and B are not like different, then something's wrong with your proof, right? So B is in S and it's not 1, right?
Yeah.
And then A is different, it's not generated by B, yeah?
Yeah.
Okay, and then the claim is then you get 2. you get the humble 2.
Okay.
All this for 2. Okay, so the way I try to prove it was I proved that if you have a B and an A like this, then you can get a smaller B. Yeah. So you get a beta that's between B and 1. Yeah.
Yes.
So if you can always do that, then you can you eventually have to get to 2.
Right.
Yeah.
Let's go.
Oh yeah, I got that, but then
That's why
I gave up.
Okay, so
Okay.
yeah, so it was weird. I was trying to do this for a long time without understanding what I was actually doing. But once I understood it, I was more confident in what I was trying to prove because not everything really works when you prove it. So the idea that I basically had, so basically like you write A, right, as a sort of a sum of powers of B, yeah. And so what that really amounts to is writing A as base B, yeah. You write A in base B, yeah. So for example, you have so A equals like the first digit plus some other stuff, right?
Oh wait, just like Oh.
And so I want to basically show that the first the A sub m, I want to show that that's b minus 1. Yeah. So in terms of like if it was base 10, I want to show that the first digit's at 9. Yeah.
Yeah.
Okay. And the reason is because okay, so obviously
Oh wait, it's not just
so obviously like if it's smaller, right?
Yeah, then you just divide by b to
And t was like 0, you just divide by b to the m and you've got the smaller number. You got something smaller than b, right?
Okay.
No, it's not 1.
Oh, okay, good.
Yeah, that's where it comes in.
Yes.
What? If it's 1. Wait, what?
Yeah, so if it's 1, right? If the leading thing is 1,
If
yeah,
it's 1, t must be 0.
then t must not be 0, yeah? And if t was 0, like if so you know what I mean when I write t? I guess I'm writing this as am bm plus t, right?
Yeah.
So if and you want to divide by
B to the m.
b to the m plus 1 or b to the m, yeah? One of those.
Oh, I see what this happens.
Shift.
Yeah.
Okay, this makes sense.
If you divide by b to the m and
You get
1,
A
that
to
means-
the M plus T on the system.
Yeah.
yeah, and then if it's 1, then that means
So
your
it
t
was like-
is 0.
Yeah.
If your t was 1, 0, then it will go above 1. Like it has to at least go above.
Yeah, so if t was non-zero, it'll go above 1, right?
Because a and
T
It is-
is 0.
Then it's a power of b.
so that's a contradiction.
Wait, what?
Because if t is 0 and am is 1, then a equals b to the m.
Oh.
Bro.
That makes sense?
Okay.
Okay. So basically, t can't be 0. Yeah?
Yeah.
Yeah. Well, or maybe you can just start with. Yeah, so you can start with t can't be 0. Yeah? So if t was 0, you divide by b to the m, and the leading coefficient would be the number you need. And if it was 1, it's a power of b, so that's not allowed. Yeah? And then t is not 0. Okay, and if t is not 0, then you can divide by. You know that t is less than b to the m, right? So you can divide by b to the m. And you'll get whatever the leading coefficient is plus 1, right?
Yeah.
And so the leading coefficient has to be b minus 1 for it to be a problem, yeah?
Okay.
Okay. Okay. So something failed here also, and I find that kind of interesting. I want to ask you guys why this failed. Okay?
Why that limits? Holy. Wait, what?
Okay, so basically the argument goes like this.
Yes.
So you assume
Are
that
you eventually
so obviously
become
like you
small?
can't do any more with b's. You have to just power a, yeah? Like you've done like
Yeah.
expressing it base b is pretty much the most you can do with the b's. You have to do something with the a's
Yeah.
for this to work. So basically it sounds really simple. Like if you have a number that starts with 9, right?
Yeah.
And you power it,
And
it can't always start with 9, right?
Yeah.
Like I didn't even realize that's what I was doing for a long time. But when I realized, I was like still stuck, but I was like I shouldn't be stuck. Right? So basically it's obvious, right? If you have a number that starts with 9 and you power it, it can't stay starting with 9, right? So how do you prove that, right? Okay, so here was my idea for the proof. So if you have a number that starts with 9, right? And you assume it always starts with 9, right? With the powers. Then what happens is every time you multiply, like every time you increase the power by 1, the digits increase very predictably, right? You know what I mean? So like if you have like it's basically the same as timesing by 10, yeah? When you times by 9.
Yeah.
So like if you have like 9 times 9, right? The digit goes to 18, yeah? Oh, so what the hell? 81, yeah? So we maybe ignore that it's not a 9, but just notice that there's like one digit make 2 digits, right?
Yeah.
And then you times it by 9 again, it'll go to 3 digits, yeah?
Yes.
You times
Eventually it doesn't work.
Yeah.
At some point eventually.
Yeah. So if it was always 9 at the start, it would always go up by 1 digit, right?
Yeah.
But if it stopped being 9 at some point, then if it's so therefore if it stopped going up by 1 digit at some point, then it has to not be 9. That's the idea of the proof.
Wait.
So
Oh wait, yeah, no, it's because you can't. Like you can't. It's too the range that you like
Yeah.
is too small.
Oh yeah, okay.
You understand what I'm trying to say? Yeah. So instead of 9s, we have b minus
Oh,
1.
it has to not be. Wait.
Okay.
Oh yeah, that's true. That's
So basically the proof is 2 steps. One is to prove that you lose digits,
oh yeah, and if
and
you
one
lose
is to prove that you
digits-
don't lose digits if you had 9s at the start.
Oh, that's so smart. That's an
Oh.
intelligent solution.
Okay.
Okay.
I did not come up with this instantly, okay? It wasn't like, oh,
Bro, I had this idea and then I was like, I give up. This is too hard for me. I keep giving up and saying it's too hard for me. I could have done like
yeah.
the questions.
Yeah, I guess this is kind of more like it's kind of more like hard work than ingenuity. You understand? Like something that looks amazing if someone came up with it in 10 minutes might not seem very amazing if it took a year, right? But you don't really know how long people take when you see the solution. So you kind of always have this. So that's why some things look more amazing than others, right?
Yeah.
There was once a time where like I would always like by default try to look for the best proof of everything, and I think I lost a big part of my life doing this. But like, yeah. Anyway, so to prove that it loses digits, yeah. So basically, what I did was, so you divide a by b to the n plus 1, yeah.
Yeah.
So it's less than 1 now, yeah. And you take a limit of the powers of that, yeah. So that's obviously 0, yeah. Even though we never really prove it in like HSC or anything. So if the limit's 0, that means
that means you have to lose something.
that means you have to. So basically, this b to the n plus 1 to the k, that's the number. Like that's basically the right amount of digits. Yeah. And so if a to the k is equal to something like something small times that, right? So it's not 100%, it's like maybe 90%, or if it's even like 1%, right? Then you have to lose at least 1 digit. Does that make sense? So there is some power for which a to the k on b to the n plus 1 to the k is less than like 1 on b, yeah?
Yeah.
I think I could be a bit more generous here. I make it like 1 on b to the million or something.
Yeah. That's fine.
Yeah.
As long as it loses a b.
Yeah, as long as it loses a b. So then it has less. So it lost a digit, right? For that power.
Yeah.
Okay, and then proving that So yeah, I'm kind of in a hurry here. So if x is bigger than maybe this is like if the digit's bigger than b minus 1, yeah? And y is also bigger than 9, yeah? The digit's bigger than 9. Then their product is gonna be, as long as b is greater than 3, or greater than or equal to 3, yeah? Their product is also gonna be this m plus 1. So like, the product is less than n plus 2, yeah?
Yeah.
So if it's bigger than m plus 1, then it's like it's kind of maximizing its digit gain, yeah?
Bro, this is so rigorous, and then if I was to write this, I would just be like, digit slow.
I feel like we've seen these kind of problems before, and we kind of treated them a little bit, I don't know, disrespectfully. I don't know, like you remember like there was like some AMO question where it was all about proving like you could power stuff so that the last digit is something, like it's like, it's obviously you can. It's just like, well, why are we even bothering to prove this?
Yeah, I think those questions are kind of hand-wringing.
Actually, it's not.
Yeah.
It's not just easy. It's not just.
We should have disrespected the question. Got asked.
Yeah.
Also, this is a proof that you can reach 2.
Yeah.
BBN plus 1. Wait, let me try this myself. I'm pretty sure. Like, I need to actually get good at this stuff. Wait, how does that? Oh, wait, that.
Yeah, no, it keeps increasing again.
Okay, so there was something that I found like very weird. Something that didn't work, okay? And I thought this should have worked because so you basically get like if you had like so your thing is between like it's less than b to the m plus 1, right?
Yeah.
And so like say it's a, yeah? And it's bigger than b to the like it's like b to the m minus 1. Yeah. Yeah. And like instead of powering it up, you square it. Yeah. So instead of just powering it with any k, you make it powers of 2. Yeah.
Okay.
So for example, you have a squared. You have b to the m plus 1 squared. Yeah. Okay. So the reason I guess they're trying to do this is because you can actually calculate the difference between those two numbers with difference of squares, right? You have b m plus 1. If you subtract it, is minus a. So that's the difference you had before, right?
Yeah.
And then you times it by plus a, right?
Yeah.
And you can actually keep doing it, right? You can keep powering up by 2. So you get like b to the m plus 1 squared plus a squared, right?
Yeah.
All the way up to like b m plus 1.
Okay.
Well, to the 2 to the l, yeah? Plus a
This stuff is kind of
to the 2 to the l, yeah?
a lot of effort.
And l gets large, yeah?
Yeah.
So that's the difference between the right number of basically the right number of digits, like, and your current value, right? And you just need to show the difference is bigger than the one beat of that. So like one less power than the top, and then you're done. So then it's not a 9. You know what I mean? So it's like the top thing is like a billion, right? 10 to the 9. You just got to show the distance is bigger than 10 to the 8. And it's not 9, right? And you actually have a formula for the distance.
Yeah.
Well,
I couldn't show it. I don't know, maybe I just missed something. I don't know.
well, what were you trying to show?
I was trying to show this expression here is greater than. Maybe it's something.
Wait, is this trying to prove that like 9 times 9 is 81?
Oh, no. It's trying to prove that 9 times 9. So 9 squared, eventually doesn't have a 9 at the front.
Oh, wait.
Not right.
Can't you just prove that 9 times 9 equals 81 and then you prove like with logs or something that they must lose it?
Astro suggested something with logs, which kind of made me not go in that direction.
Okay, well then that is not very nice.
Okay, so you want to show this is bigger than m plus 1 2 to the L plus 1, right? L
Yeah.
B m plus 1 minus
minus 1, yeah? Wait. Is it minus 1 or minus b? Minus. It's minus. It's over b.
Hey, what's happening?
Yeah?
Hey, what's happening?
Wait. I think. Wait. Okay. Yeah. I think. They have to work.
How does technology
So if you look at all these terms here, right?
I don't understand this.
Then you get like 1 plus 2 plus 4 plus you get the sum of powers of 2's, right? So then you end up getting b to the m plus 1 to the power of to the power of 2 to the l plus 1 minus 1, yeah? So in some sense you're missing like a b to the m. Yeah? Does that make sense?
Yeah.
Hmm. So and if you literally like factorize all the b to the m plus 1's out of each factor, right? You get 1. So you can think of a as a is bigger than b to the m. So a is equal to b to the m plus 1 minus b to the m plus something, yeah? So then if you factor out the b to the m plus 1 from each of these factors, then you get 1 plus 1 minus 1 on b plus t on b to the m plus 1, yeah? And the general term will be like to the power of like I, and this will be to the power of I, yeah?
One to the power of I.
Yeah. So if t was like 0, right? If t was 0, it'd be like 1 plus 1 minus 1 on b to the power of like I, yeah? Maybe it is. It has to be true.
Wait, at some point, at some L, we want that to happen, right? Like we want the inequality.
Yeah.
But like, if you look at your greater one, if you increase L by 1, then you're timesing it by b to the m plus 1. To the power of 2 to the m plus 1. Right? If you increase your L by 1 more,
Yeah.
then you're timesing that side by that much.
Yeah.
On the other side, you're timesing it by b to the m plus 1 to the power of 2 to the l plus 1 plus another a to the 2 to the l plus 1.
Yeah.
So you're timesing by something bigger.
Yeah.
Isn't that just done? Like if you time stuff that are constantly bigger, and that a is like. But it doesn't matter. A can be
But the a is getting smaller. Like
the a is getting smaller.
Like the a to the the bigger power on the a makes the a a much smaller relative. Like the a is like this 1 minus 1 on b. That's what the a is like. So like if you have a number, like 1 plus r, right? And r is like smaller than 1, yeah?
Yeah.
And then you take it to the power of n.
Yeah.
And you take the product of this, as n goes to infinity, yeah?
Yeah.
Like, is it? It's not even clear that diverges. Like it's not even clear that's unbounded. I don't know.
Where r is less than 1. That's
Yeah.
what you're saying. Because you're saying r is less than 1 because if we compare it to like the size of b to the n plus 1.
Yeah. So once you divide out the b to the b, you get a 1 plus That's essentially what it is, right?
Yeah, it is. Wait.
So it's bigger than B by R to the n percent or whatever.
Wait, but can you just divide B to the n? Because like some of them are higher powers. So what do you do about that? That's technically not just one. That's like.
Like I write. So for example, this factor here, right?
Yeah.
I just divide this factor by b to the n plus 1. Yeah.
Okay,
And then I divide this factor by b to the n plus 1 squared.
Okay.
And this one,
Okay then, but if you divide all of that, then wouldn't your greater sign be like greater than some like? It wouldn't be too good to tell. Oh wait, no, wait.
Yeah, it'd be like. So then whatever's left over, you want to say that eventually exceeds b to the m or something like that, right?
Yeah.
Which should be true.
So you have to you kind of just have to prove that diverges.
Yeah, but I don't even know if it does. Like,
I don't know why that doesn't look like it does. Oh, actually no, but I think it is.
yeah.
I think it is.
What would the limits do?
Yeah, no, I think it does diverge. Yeah. No, it has to. Proof.
I tried proving that. Okay, do you want to? I tried proving it with the ratio test. Okay, and I got the conclusion that it converges.
Huh?
Wait, is it true that this converges? Like, if you take the log of it,
Yes.
yeah, it converges and diverges. You can take the log of it, right?
Yeah.
Okay.
Then you get a sum, and we're more familiar with sums. Oh. What was that? What was that convergence test I taught you for AP calculus?
Ratio
test.
ratio test. Just adjacent terms and then
Cool us going through this.
Okay, maybe we can, as an exercise.
But next time we see that.
Oh. We can maybe we can do it as an exercise to determine if this thing converges or not. Yeah. There's a ratio. You're crying a little bit too much here. Alright.
Oh my god. Can you do magic tricks?
that is not what the point of the mask is.
Skybridge.
I can't do it.
Skybridge.
Skybridge.
You have to do the reverse.
Oh my god, no.
Skybridge.
Sorry, I did a bridge or whatever that is.
In bed wall.
Yeah, like I'm pretty like half. You can easily get half a jigger cost, and then you just like bridge with these staircases.
I play bed wall. Yeah.
Hey,
Don't worry, I remember the amount of blocks.
Racially profiling.
It takes exactly 30 blocks.